Hi, I'm going to present you the results for Team 6. Our project was about improving the embedding space for image representations in self-supervised learning. As a recap, we want to do self-supervised learning because then we can use the large unlabeled data sets, whereas creating annotations, labels for images is time-consuming and expensive. The general idea for the learning is that we want to map an image and all its augmentation to possibly the same representation, while mapping different images to dissimilar representations. There has been rapid improvement in recent years in this field, with the performance now quickly approaching those of supervised learning models. Our main baseline will be subCLR, which uses a set of different augmentations representations and then trains with the objective of moving the two augmented versions of the image in each batch together, while moving all other augmented images away. What we've observed is that the image space for some CLR, that the embedding space for some CLR is rather convoluted, and the classes are rather close together. We've visualized this in this heat map of the cosine similarities between the class means on the right. We can see that for many categories, the class centers are rather, the mean representation of the classes are rather similar. We also observed that this is a problem in supervised models using cross entropy, even though it is less dark there. We tried many different things, and what we found to work was adding a term to the loss, creating a proposed distance enhancement loss. What our key idea is adding the term on the top right to the SimCLR loss. What this term does is that it says that explicitly trains the models to make the cosine similarity between two different images dissimilar, eventually forcing the model to make them orthogonal to each other. Since the original objective of making the augmentations of the same image to the same representation is still crucial, we introduce a lambda parameter to balance the original objective with our addition. We also found that we can use this to improve the results of supervised learning by adding our term to the cross entropy loss. All our experiments, including the heat maps and the t-SNE plots I've already shown you, use the CFAR10 data set, and we used a modified SimCLR implemented with PyTorch Lightning, always with a ResNet 50 backbone. As an evaluation metric, we proposed a negative log absolute determinant, or NLAD for short, which is a single number metric derived from the cosine similarity metrics I've shown you before. It ranges from 0 to infinity, where a smaller value is better. We found that our new loss does indeed move the classes further apart. You can see in the left column the baseline models, and in the right column our improved models, where it is clearly visible that the mean representations of the class move further apart. This is also represented in the NLAD, and we even found that it improves the classification accuracy over the classical cross entropy. Having a better embedding space also means that we improve the results when performing clustering, as shown in the t-SNE plots below. So to sum up, we investigated a problem with the embedding space in self-supervised learning, have added a new metric to quantify how well this problem is solved, and show a new loss which can tackle this problem.
Okay, thank you. Any question? I have a question. So can you show me the experimental results again?
Yes.
Yeah, this one. Yeah. So yeah, I think I missed, but what was the score mean? The 1.62 is the error rate?
This is the negative log absolute determinant. So it essentially summarizes the similarity matrix shown on the left in a single digit. And if it became 0, then all the mean representations of the classes would be orthogonal to each other, which would be the ideal state of an embedding space.
Wow, this looks too good. I mean, it's much better than the supervised, right?
For this metric, yes.
Yeah, okay. Yeah, I'm going to read your paper first, and probably we'll get back to you to some more questions. Okay, thanks.